Hello YouTube. This video is going to cover adding whole numbers together that add up to more than having 10 of something. So for an example, like 7 plus 5. If you looked at my other videos, I commented how digits in these positions, in the first position, is called the ones place, and they represent having so many ones of things, like 7, 2, 3, 4, 5, 6, 7 individual items of something, like $7. We can think of this as money. Instead of having seven $1 bills, and your friend, say Timothy, gives you five $1 bills. So together you would have 12 $1 bills. 1, 2, 3, 4, 5. You'd have 12 of them. However, in math, once you get 12 of something, we don't have a single number to represent that. We don't have like a triangle or a square that represents. This means 12. Like, we don't have anything that does that. So what we do is, as soon as we get 10 ones, we go to the cash register, a restaurant, a friend, or something, or someone, and we convert 10 ones into a $10 bill, right? 10 ones is the same as a $10 bill. And what we have left over is two ones. So we say 7 plus 5 adds up to 12, but in 12 we can get one $10 bill and two ones. We leave the two ones here, and we take the rest of the 10 ones and convert to one $10 bill. And then we usually write that like up here. And then we say, so now we're going to see how many $10 bills do we have. Well, we have zero $10 bills that we started with. He's giving us zero $10 bills. The only $10 bill we have is the one we converted from our 10 ones, and then we have one $10 bill. Okay? So now we write this. We have one $10 bill and two ones. 7 plus 5 is 12. We'll do one more quick example, then go into a harder problem. The example I want to give you right now is just a number, say 568, okay? So if we think of this as money, the 8 represents what's called the ones place in math, the ones. And this can be how many $1 bills we have, 8 $1 bills. Okay, we have 8 of them. The 6 represents the tens place in math. And this, if we're thinking of it in terms of money again, represents having 6 $10 bills. And each one of these is a $10 bill. So right there you can see we have $68. Okay, 6 tens plus 8 ones. That's $68. And 10 of these makes one of those. Alright, and now we have 5 $100 bills. We actually have quite a bit of money. So these are 100s. We have 5 of them. So we have 5 $100 bills. So this is called the hundreds place. I'll just do HUND to abbreviate. Let's just add a number to that. So we have $568 in our pocket. Our friend Aaron owes us, say, $56. So we're going to add $56 to our current $568 we have in our pockets. Now notice that since it's giving us $56 in math, always think of the money in terms of how many tens does he have and how many ones does he have. So if he has $56, he has to have exactly 6 $1 bills, represented here, and 5 $10 bills. Now obviously in real life money there's different ways you could have $56. You could have it all in quarters, you could have it all in $1 bills, but mathematically it's useful to think of him as having money in $10 bills and $6 bills. And that's just because of how our system in math works. So let's just add up all our ones to this. We have 8 ones plus 6 ones. We could use our fingers, or if we just know it, we know that's going to be 14 ones. And just like before, since we got to 14, we now need to convert 10 of those ones into a $10 bill. So we go up to someone and say, hey, can you give me a $10 bill? I have 10 ones. And we'd have 4 ones left over. So if we have 14 ones in total, we convert 10 of the ones to a $10 bill, and we put it up there. We're going to add it to the rest of our $10 bills. And note how this doesn't change our total. Having one $10 bill and a $4 bill is the same as having 14 $1. So we're not changing how much money we have, we're just changing how we're holding it. We're holding it in the term of a $10 bill now. So now we have 4 ones, and here's the 10, so we have 14 together still. But now we're going to add up how many 10s do we have, since we converted the 10 ones to a $10 bill. So we're going to do 1 plus 6, is the one we converted, plus 6 is 7 $10 bills. And now we're going to add 5 more $10 bills to that. So 7 plus 5, you could use, add 7 to 5 $10 bills right here. Or, yeah, rather we'd have to add 6, right? Yeah, we have to add 6. So, and then we'd get 12. We can count it out that way. So 7 plus 5 is 12, however you want to get it. Now, when you get 10 10s, again, you're going to have to round up because we have no single digit number that can represent 10 of anything. We don't have a triangle or something we can put here that says, hey, that represents 10 10s. We don't have anything that represents 10 of something. So once you have 10 10s, we have to go up to the next place. And 10 10s is the same thing as $100. So as soon as we get 10 10s, we go up to the clerk and say, hey, can we turn these 10 10s into a $100 bill? And they simply swap it out for us. And it's worth exactly the same. So we have 12 10s. We're going to keep 2 of the 10s in normal form. And we're going to change 10 of the 10s into a $100 bill. And now we're going to say, what's 1 plus 5? So $100 bill we just converted. We already have 5. So that's $600 bills now. And is Aaron giving us any $100 bills? Nope, he's providing 0. So now we have a total of 6 $100 bills. So now our answer is 624. So that's a little insight of what you're doing when you're converting, why the amount isn't changing. You're simply doing 10 ones into a $10 bill. It's the same thing. It's just a different form of the currency. So if you had $10 in your pocket and you go and trade someone for 10 ones or vice versa, you're not going to change how much you have. And that's exactly what happens here when you carry. That's all carrying is. You're carrying 10 10s for 100. 10 hundreds could get turned into 1,000. That's exactly what carrying is. Let's look at subtraction really quick. So we have $624. We're feeling pretty rich right now. So $624 in our pocket. But we want to buy a lollipop. But we don't want to buy just any lollipop. We want to buy a massive lollipop. So we go to our friend Willie, and we're like, hey Willie, how much are your lollipops? Well, Willie makes these special lollipops, and they're called Wonkas. So he's like, how much is your Wonka lollipop? And he's like, it's $89. We're like, that's really expensive, Willie. And he's like, yeah, but it's everlasting. We're like, okay, sweet. We'll buy your $89 lollipop. So we have to pay this guy $89. The way we want to think about that is paying him 8 10s and 9 1s. So we have to take that away from how much we have. So let's just minus 89. So this means we're losing money, this minus sign. We're subtracting. Alright, let's just make that 8 a tad nicer. There we go. That's the stuff. Alright, so we have 4 $1 bills. And we're like, hey, I know I owe you 9 ones, but I have 4 only. So what I'm going to do is, I'm going to go to Jeremy. He's my banker. And I'm going to convert one of my $10 bills into 10 ones. So now I have one $10 bill left, and I have 10 $1 bills. So now what's 14 $1 bills minus 9 $1 bills? Well, I can just use my fingers and count what's the difference. How many would I have left after I paid him 9? How many more ones are in 14 than there are 9? So we can say 10, 10, 11, 12, 13, 14. So there's 5 more ones in 14 than there is 9. So after I pay them all off, I'm going to have 5 ones left. Okay? So now I don't owe him any ones. I paid him all 9, and I have 5 ones left. I also only have one 10 left because I had to convert one of my 10s into 10 ones. Now he's like, all right, well, where's the rest of my 80 bucks? You're like, well, geez, Willie, give me a second. So you check how many 10s you have in your pocket. You only have one 10. And you're like, well, I owe you 8. So I guess I'm going to have to go break a $100 bill. So you go to D Nice this time. She's a friend of yours, and you know she's rich. And you take one of your $100 bills and you convert it into 10 tens. Now you only have 5 $100 bills, and now you have 10 tens. Plus you already have one 10, so now you have 11 $10 bills. You owe him 8. So 11 minus 8, after you pay him out the 8, you would have 3 left. You can use your fingers to do that. If you just have it memorized, that would work too. So you'd have 3 tens left. And now you have 500s left because you had to break one. And you owe him 0 $100 bills. So 5 minus 0 is 5. So after paying him $89, you have $535 left and a nice everlasting popsicle. Is that what I call it, popsicle or sucker? Lollipop, yes, I'm talking about lollipop. It's not a scam at all, trust me, it works. One last thing, just to kind of get your brains going here. If the thing cost $1 more, if you owed this guy $1 more, so the lollipop was 90 bucks, how much money would you have left without going through it again? So let's say you're minusing 90. Here's what I want you guys to be able to do is if it cost $1 more, that just means you owed him $1 more. So you already paid him 89. So after you paid him 89, you have $535. So if it just cost $1 more, that means you still owe him $1 if it say cost 90. So you'd end up with actually $1 less here. So it'd be 534. Okay? So if the thing actually cost 90 bucks, your answer should have been 534. What if it cost 94 bucks? Well, it should be $4 less because you still owe him $4 after this. This means you paid him 90. So if it costs 94 bucks, you should have 530. And you should be able to just kind of do that in your head without having to redo all the math. You know, if you just think about how many things do you owe him and how much did you pay him. To illustrate this simply, to end this video, let's look at like 7 minus 5, a real simple number, alright? We know that's 2, okay? Let's say you wanted to pay your friend $1 at a time, okay? So you have 7 bucks, and you're just kind of messing with your friends. You're like, hey, you know what, I'm just going to pay you $1 today, and I'll pay you more tomorrow. So the first day, you only pay him $1. So you have 7, so you pay him $1. So you're going to have $6 left. But you paid him $1. So now you only owe him 4. Okay? We already know this is 2. So let's just kind of see what's going to happen here. So let's say you're going to pay now the rest of the money today. So you have 6, you give him the 4, now you still have 2. And the idea here is that it doesn't matter how you pay out this 5. If you only have 7 and you give away 5, you're going to be left with 2. So it doesn't matter if you do it $1 at a time, $2 at a time, $3 at a time, you're going to be left with $2 at the end. So one trick you can do with numbers, if you feel it's going to make it easier, if you're doing 199 minus 80, I don't know, say 80, right? And for whatever reason you think this is difficult for you, which I don't really see this problem as difficult, but if it was, one thing you could do is say, well, what's 200 minus 80, right? But if you did 200 minus 80, you gave yourself an extra $1. You have $1 more than you should have. But we know 200 minus 80 is 120, okay? But you gave yourself $1 more than you should have. So this means you have $1 extra in this pile than you normally should have. So it should actually be 119 if done correctly. And if you do this, 0. 9 minus 0 is 9. 9 minus 8 is 1. 1 minus 0 is 1. 119. So there you have it, folks. Just some tricks to do with numbers, some ways to interpret them. Hopefully this will help you in your math classes, just lining up the numbers correctly and understanding what you're doing a little bit better.